Hello students, hope you are doing fine. So I am Dr. Murugan. So PSM. So welcome to this session on this calculations in PS. Fine. So what we are going to see here in this topic in this video, okay. We are going to discuss a few important topics. We are going to discuss important topics that has been previous year question from various exams we are going to do. Fine. The first is, let us see this question. Okay, a study with the new drug, new treatment, there were 36 deaths, 36 deaths out of sample of 120, and with the new drug there were 26 deaths out of sample of 130. How many patients should be treated to prevent one death? First, what study is this? Okay, what study? Look here. So they are giving drugs actually. That means, so they are giving, it's an experimental study. Experimental, more correctly means it's RCT. Okay, RCT. Okay. So what they have done, they have divided the people into two groups. Okay, that is a new drug and a old drug, existing drug. Okay, this is what they do. Okay, this is what they did. Now, okay, what they're asking, okay, the question is, okay, how many patients should be treated to prevent one death? What exactly they're asking? It is an RCT. What exactly they're asking is N and T. What is N and T means? Number needed to treat. Okay, that is N and T, number needed to treat. Okay, what is N and T means? Okay, so formula is 1 by ARR. What exactly N and T means? Number of patients to be treated, okay, to prevent one bad outcome. So how many patients should be treated to prevent one bad outcome? This is NNT, number needed to treat. So the formula for NNT is 1 by ARR. What is ARR means? What is ARR? ARR means absolute risk reduction. Absolute risk reduction. ARR. The formula for ARR. What is the formula for ARR? Absolute risk reduction is, ARR is control event rate minus treatment event rate. Okay, what is the event rate in the control group minus treatment event rate in the treatment group? Okay, fine. Now, so what we'll see the question now. We'll go to the question now. Look here, the question. Control group, there were 36 deaths out of 120. So control is 36 by 120, and the new drug treatment is 26 by 130. Okay, 26 by 130. Now, so now they're asking NNT. Okay, we will see this right now. So control event rate minus treatment event rate. Control event rate minus treatment event rate. How much is the control group? Control group is 26. Okay, control group is 36 by 120. 36 by 120. 36 by 120 minus, okay, treatment new group is 26 by 130. 26 by 130. Now, how much the value comes? If you divide it, okay, by, let us divide it by 12. Okay. So this is 3 by 10, and this minus, this is 13. So this is 2 by 10. This is 2 by 10. That is 0.3 minus 0.2. That is 0.1. This is ARR. What is ARR? Is absolute risk reduction. But what we want, actually what we want is NNT, number needed to treat. So number needed to treat is 1 by ARR, that is 1 by 0.1. So NNT is equal to 10, guys. NNT is equal to 10. What does it mean? Okay, If you treat 10 patients with the new drug, what does this means? So if you treat 10 patients treated with new drug, okay, so one death can be prevented. This is what is NNT is. If you treat 10 patients if you treat with the new drug, so we can prevent one death, we can prevent it. This we call it as number needed to treat. We'll go to the answer. So what is the answer here? So how many patients? The answer here is 10. NNT is 10. Number of patients to be treated to prevent one bad outcome. Hope this is clear. This is a PYQ of INA exam. Okay. So this is number needed to treat. Where we will do it? This we can do it in the case of RCT, randomized controlled trial. We'll go to the second question. The study was conducted in two different samples. Okay. Sample A has a mean and standard deviation of this value 110 plus or minus 10, 11. Sample B, the mean and standard deviation is 18 plus or minus 3. Which sample has more variation? So you have two samples with the mean and standard deviation. We don't know the units actually. So they are asking comparing, they want us to compare the variation between the groups. So what we can use here is coefficient of variance. Coefficient of variance. A coefficient of variance. What is the purpose? Used to compare variation between groups. Used to compare the variation between the groups. So you have two groups are there. So which group there is more variation? Okay, fine. So because the two different sets, maybe height and weight, if you see, they come in two different units. Okay. So variation here is this standard deviation. Standard deviation is the variation. Okay, but maybe in two different units and practically very difficult actually. Fine. So let us see the formula for coefficient of variance. The formula for coefficient of variance is SD by mean multiplied by 100. A standard deviation by mean multiplied by 100. It comes in percentage, guys. Percentage. Okay, fine. Now let us see this, calculate this. So 110 plus or minus 11. Here 18 plus or minus 3. So first let us take A, sample A. Sample A. Okay, so what is the formula here? SD by mean multiplied by 100. So SD is 11 by 110 multiplied by 100. So 11, 110. Okay, so 11 by 110 multiplied by 100. So mean is how much? Mean is 11. Okay, yes. So mean percentage. Okay, if you do the percentage, so how much it will cut? So this is 10%. You will get 10%. Now you'll go to B. Okay, B is same thing, 3 by 18 multiplied by 100. So 300 by 18. Okay, it will come 300 by 18. It will come around 16%. Okay. Now tell me which one there is more variation is there. Okay, there is more variation in sample B compared to sample A. When compared to sample A, the variation is more in sample B. So this we call it as coefficient of variance. So answer for this is sample B has more variation compared to sample A. So this is coefficient of variance. Okay, we used to compare the variation between groups with different units. Okay, or just two different groups also you can compare, because you're going to convert the value into percentage. So if you see in percentage, it's easy to compare. Fine. We'll go to the third question. Fine. So I hope this is going well. If you have any doubts or queries, you put it in the chat box. The intraocular pressure was measured in 400 people. Okay, the mean was found to be 25. 400 people. Mean was found to be 25 millimeters. Standard deviation was found to be 10 millimeters of mercury. 95% confidence interval. What is this 95% confidence interval would be? What is this confidence in? What is confidence interval? Okay, confidence interval is, okay, estimated range of values. The range of values, okay, likely to include population's original value. So estimated range of values likely to include the population's original value. So you are going to research. So I am doing a study in a sample. Okay, so I am getting some results. Okay, so whatever results I am getting, I am going to in a sample I am doing it. When I want to generalize it to the population, okay, I cannot say this is the same value will be there for the population. So what I will do is that I will give my results in the form of range. If that range is confidence interval, within, I will say that within the range the original value will fall. So 95% of the times population's original value will fall between this range. Now, so what they have given here. Okay, so what is the formula? The formula for, okay, confidence interval. Okay, the formula for 95% confidence interval. Okay, so mean plus or minus 1.96 standard error. This is the formula, guys. Mean plus or minus 1.96 standard error. What is the formula for standard error? Standard error is standard deviation, okay, by square root of. This is the formula. Standard error is standard deviation by square root of. Now mean, we will start with the mean. Okay, what is the mean there? Okay, what is the mean? Mean they have given it as 25 millimeters. Standard deviation of 10 and n is 400. So we will calculate here. The mean is 25 plus or minus 1.96. What is standard error? Standard deviation by square root of n. So what is the standard error? Standard error is what? 10. Okay, what is n? N is 400. So n means number of people you did the study, that is 400. So look here, that is 25 plus or minus 1.96. Okay, so 10 by, what is square root of 400? This you should know. Basic mathematics we should know. Yes. So that is, yes. So 400 is how much? 20. So that is 25 plus or minus 1.96, 0.5. So if you do roughly, it comes like this. Okay, 25 plus or minus how much? 1.1. Okay, roughly 1. Okay, 1.96 multiplied by 0.5. Roughly 1. This is 95% confidence interval is 24 to 26. So I can say that within the range 95% of the times population's original value will fall. Okay, I'll repeat again, guys. I'll repeat again. So answer is 24 to 26. I'll repeat again. So what is confidence interval? It is the estimated range of values which likely to include the population's original value. Right now. So they ask for 95% of confidence interval. That means 95% of the times population's original value will fall. Sometimes 90% also can be asked, 99% also can be asked. So what is the formula here? Formula is mean plus or minus 1.96 standard error. So the standard error formula is standard deviation by square root of n. This is what, okay, this is the formula, this is square root of n. So we substituted here, standard deviation is 10, n is 400, mean is 25. If you do the calculation, the value comes as 95% confidence interval is 24 to 26. Okay, so we can say that 95% of the times population's original value will fall between. So am I clear? Fine. So if you have any doubts, you post it in the chat box. Next question. Okay, these all have been PYQs, previous INICET and probably some NEET exam question. Now in a population, okay, there are 100 people are there, 100 people. Prevalence is 20%, sensitivity is 95%, specificity is 80%. What is the positive predictor? So we will see one by one. Okay, what is the formula for sensitivity? Sensitivity is true positives by false negatives multiplied by 100. Formula. Specificity. What is the formula for specificity? True negatives plus false positives multiplied by 100. This is the formula for specificity. What is the formula for positive predictive value? Positive predictive value. Numerator is true positives, denominator all are positives. okay, multiplied by 100. So the denominator is true positives by total positives. Okay, all are positive. Now, so who is these people? So sensitivity deals with only diseased people. Okay, what about these people? These are non-diseased. Non-diseased. They are diseased and these are non-diseased. Now let us calculate this. Okay, they have said 100 people, prevalence is 20%. Let us make a 2 by 2 table. Let us make a 2 by 2 table. Look here, we are comparing a screening test with a diagnostic test. Always the diagnostic test should be there in the x-axis. Diagnostic test always. Screening test. Screening test should be there in the y-axis. Okay, this is always, guys, always. Okay, it should not change. At whatever cost, it should not change. Screening test always should be there in the y-axis. Diagnostic test always should be there in the x-axis. Now what is the total population they have given? Total population is 100. They said that the disease prevalence is 20%. What is 20% of 100? Disease prevalence is 20%. What is 20% of 100? Yes, this is 20. Remaining is how much? Am I clear? This they have given. Okay, total population is 100. Okay, out of them 20% of disease prevalence is 20%, that is 20. Remaining is 80. Okay. Now what is the formula here? What they have given, we have to fill the remaining rows and columns. Okay, sensitivity they have given it as how much they have given sensitivity? Sensitivity 95%, specificity 80%. Okay, sensitivity 95%. Sensitivity they are given 90%. Okay, what we already know. Okay, fine. Now, so what is the formula for 95 is equal to true positives by true positives plus false negatives multiplied by 100. Multiplied by 100. Okay, now look here. So how much is the value here? Okay, so what is this one? This is true positives plus false negative. What are they? They are the diseased people. They are actually, these are the people, diseased people. Diseased people. So what you are going to do? So okay, true positives by 20, 95 multiplied by 100. Am I clear? If you do the calculation, okay, so if you do the calculation, true positives will be, you do the calculation, so it will be 19. True positives will be 19. So am I clear? True positives, right? So this is 19. This is 19. Okay, how much is out of 20? 19 goes. Remaining is 1. You can put it. Now, specificity. What is the formula we said for specificity? Specificity is true negatives by true negatives plus false positives multiplied by specificity. Okay, true negatives by true negatives plus false positives multiplied by 100. Now, so what is the value here? What is the value? Okay, true negatives is how much? That's what we have to find out. Specificity is 80%. True negative, what is this one? This value is this 80%. So 80 multiplied by 100. True negatives is 6 into 8 into 8, 64. This is 64. Remaining is how much? So out of 80, 64 goes means, okay, this is how much? 16. So what is positive predictive value? So this is true positives, true negatives, false positives and false negatives. Now, what is the formula for positive predictive value? Is anyone can tell? Is what is the formula for positive predictive value? True positives by total positives. What is true positives? True positives by total positives plus false positives multiplied by 100. How much it is? 19 by 19 plus 16 multiplied by 100. How much the value goes? 19 by 19 plus 16 multiplied by 100. How much it goes? So it comes as around 19 by 35 multiplied by 100. So roughly approximately around 54.5%. So it comes as 54.5%. I'm repeating again. Okay. The answer for this question is around 54.54. The answer. Roughly this is the answer. I'm repeating again. Okay, first you take this, make this table. So first you fill up the total number of people that they have given 100. Out of 100, the disease prevalence is 20%. Okay, so 20 you put it. Remaining is 80. Now substitute it in the formula. Okay, once you substitute in the formula, so since true positives comes as 19, true positive comes as 9. You have to just substitute in the formula. Okay, fine. So again, specificity you substitute in the formula. True negatives comes as 64. Okay, based on that, you can fill up this table. So positive predictive values, true positives by denominator is total positives. Total positives. So what is the answer you are going to get? So answer is 19 by 35 it will come. It will roughly around 54.3%. Right. Hope you understood this concept. The PYQs of the previous INA exam. In an investigation to study the effect of smoking on renal cell cancer, it is observed that 30 out of 50 patients were smokers as compared to 10 out of 50 control subjects. The odds ratio of renal cancer with smoking will be. The question they themselves given odds. What study is this? The case control study. A case control study. It goes from outcome to exposure. Goes from outcome to exposure. The case control study. It goes from outcome to exposure. Now, so what is the question they are asking is odds ratio. Odds ratio. Odds ratio, what is the formula? Odds ratio, what is the formula? Formula is AD by BC. Formula for odds ratio is AD by BC. What does odds ratio will tell? Odds ratio will tell strength of association. Okay, odds ratio will talk about strength of association. Between two parameters, what is the strength of association? Strength of association. The odds ratio equal to what? No association. More than 1 means positive association. Less than 1 means negative association. The odds ratio equal to 1 no association. More than 1 positive. Less than 1 means negative association. Negative association. Now, let us go to the problem. We will do the calculation. So they said that 50 cases, 50 controls. Among them 30 were exposed. Among controls 10 were exposed. Now we will do the 2 by 2 table. Do the 2 by 2 table we will do. So you have to take cases and control. Cases and controls you take it. So in x-axis exposure positive and negative. Okay, exposure positive and negative. Right now, how much is the total number of cases? Yes, we saw that 50 guys. 50 cases and 50 control. Among the 50 cases, how many were exposure positive? 30. Remaining is 20. Among the controls, how many were exposure positive? 10 and 40. Remaining is 40. Now, what is the formula we said? Formula we said is AD by BC. AD by BC, A, B, C, and D. AD by BC, A, B, C. Now, what is the answer? What is AD by BC? So, AD by BC. So, what will be the answer? Okay, 30 multiplied by 40 divided by 20 multiplied by 10. So 12, this is 6. Okay, so the odds ratio comes as 6. Odds ratio comes as 6. What does it mean? What does it mean? Yes, is it what type of association? Odds ratio comes as 6. Okay, that means more than 1. Yes, it is a positive association. So positive association, answer is 6. Okay, answer is 6. So the question is between smoking and renal cell cancer. What does it mean? Okay, so you can say this way also. Smokers are, okay, or people with renal cancer are, okay. People with renal cancer are 6 times more likely to be associated with smoking when compared to those who are not having renal cancer. Means cases are 6 times more likely to be exposed to smoking when compared to whom? Is when compared to controls. Cases are 6 times. People with renal cancer are 6 times more likely to be exposed to smoking when compared to people who are controls. Who is a control? Control means people without disease. Without disease. I hope you understood the concept. We'll go to the next question. The last question. Last. Fine. The population of 9,000. Okay. 2,100 were alcoholic. Were alcoholic among them. 70 alcoholic and 23 non-alcoholic developed cirrhosis. What is attributable risk? Attributable risk is the formula for attributable risk is incidence among exposed minus incidence non-exposed. Incidence among exposed by incidence among non-exposed by incidence among. You can write in short form also, you can write this multiplied by 100. It comes in percentage. Okay, so incidence among exposed minus incidence among non-exposed by incidence among exposed multiplied by 100. It comes in percentage. Okay, fine. Now, so what does this attributable risk say? Attributable risk says that how much percentage of disease is attributed to the exposure. How much percent? Now, so what is incidence? Incidence means number of new cases. Formula. So let me write in short form. Incidence among exposed. Right. Number of new cases. Okay. So 70 alcoholics. New case is 70. The population at risk. How much is the population at risk? 2,000 multiplied by 1,000. Usually incidence we express in terms of 1,000. So roughly what 700 by 21 guys. Roughly around 700 by 21. This comes around 33 point per 1,000 population per 1,000. Roughly I'm saying. This is incidence among exposed. Incidence among non-exposed. Okay, new cases by non-exposed population. Okay, new cases by non-exposed population. So how much is the new case? 23. How much is the non-exposed? Total population is 9,000 minus 2,100. So 6,900. Okay, non-exposed is 6,900. So here comes as 23 by 6,900 multiplied by 1,000. So how much it will come? 230. 230 by 16, roughly 70. I think this comes around 3.3 per 1,000 non-exposed population. 1,000 non-exposed population. So let us substitute in the formula. Okay, let us substitute in the formula. So formula is incidence among exposed 33.3 minus 3.3 divided by 33.3 multiplied by 100. It comes in percentage. Comes in percentage. So 30 by 33.3 multiplied by 100 comes as 90%. It comes in percentage, 90%. So what does it mean? So the attributable risk is 90%. So what does attributable risk says that how much percentage of disease is attributed to the exposure? How much percentage of here? How much percentage of disease attributed to the exposure? Attributed to the exposure. How much percentage of disease is attributed? So in this problem, okay, how much percentage of disease? So the answer for this question is 90%. 90%. Okay. So that means so among alcoholics, okay, among alcoholics, okay, 90% of liver cancer is because of alcohol. Okay, among alcoholics, that means 90% of liver cancer, okay, among alcoholics is due to what? Alcohol. For 10% some other cause is there, but for 90% of liver cirrhosis in alcoholics because of alcohol. Okay, if you say population, then it becomes population attributable. Okay, the question is related with attributable risk. So how much percentage of disease is attributed to the exposure among exposed? Okay, I'm repeating again. This is attributable risk. Formula is incidence among exposed minus incidence among non-exposed, right? Incidence among exposed multiplied by 100 comes in percentage. Okay, percentage, right? So you substitute it here. So we have this 2,100 exposed. among them 70 developed diseases, so that is 33.3. Okay, people non-exposed is 6,900, among them 23 developed disease, that is 3.3. okay, you just do the calculation. So what you will get is, how much you will get? 90%. Okay, fine. So hope you learned from this video. It's a short video on calculation. There are past repeated questions of INI as well as NEET exam. Okay, hope you learn from this video. Okay, if you have anything, okay, please post it in the chat box. Please post in the comments. Okay, I will answer you. Fine. Thank you.